pleasure for me to introduce our speaker today, Samantha Simard, who is defending her thesis. My name is Gerald Holmes, and I've been Sam's mentor through this process. And I want to take a few minutes before she gets started to introduce her. She started here with us at the Strawberry Center the summer of 2021. She was a student at Southern Utah University in Cedar City, Utah, and she was here for the summer and looked us up somehow and got a job working with us for the summer. And when you do something like that, it's a good idea to find ways to add value to anywhere you join. And Sam did that. Sam didn't just come in and collect a paycheck for a couple months and then go back to school. She came in and said, wow, what's all this, and how do I get involved, and how do I learn, and how do I contribute to this? And that was a very good sign for us. And she really enjoyed her summer, I think, and we enjoyed having her. And she came back for a second round of that. And by then she was getting close to finishing up at Southern Utah. So she finished there in 2022 with a bachelor's degree, summa cum laude, in resource management, wildlife resource management. And then, of course, what comes next? Since she had done this with us and had a good experience and was interested, she thought about doing a master's. And so she started immediately on a master's degree with us, and that would have been September of 2022. And so I've had the pleasure of serving as her mentor. We meet weekly to talk about progress, to talk about what's going on in her project, and it's really a pleasure to work with somebody who's conscientious and hardworking. And it's great to see a good showing of support here today. So without further ado, Sam, anxious to hear about your 2 years of research.
Thank you again to everyone for being here and supporting me. Today, I will be discussing my graduate project, and there's two parts to this thesis. So the first trial or part is the survey of soilborne pathogens infecting strawberries in the Oxnard growing district. The second part of my thesis is a little bit more plant physiology based, so we'll be discussing the effect of planting day and chill treatment on yield of strawberry. Oh no. Okay. I'd like to thank my graduate committee, my main advisor, Dr. Gerald Holmes, my committee member, Dr. Shashika Hiwa-Vitharana, and Dr. Mark Hoffman, who is attending via Zoom today from China. You may ask why I have a committee member for North Carolina State University. The second part of my project that is a bit more plant physiology based was conducted in partnership with North Carolina State University. So that's the reason for that. I'd like to acknowledge all of the current and former Strawberry Center undergraduates and graduate students, in particular, the graduate students Mary Steele, Joseph Ramirez, Cooper Calvin, and Marina Gutierrez for their partnership and support throughout the duration of my thesis. I'd also like to acknowledge the current and former Strawberry Center staff for all of their continued support in countless ways throughout the duration of my master's. I'd like to acknowledge our funding sources. The first project was funded by the California Strawberry Commission, the second by USDA NIFA. I'd also like to acknowledge our collaborators. That includes Dr. Peter Henry of the USDA, Dr. Kelly Ivers from Driscoll's Incorporated, Andrew Molinar and Jason Sherritt, both from the California Strawberry Commission, and Michael Palmer and Ibrahim Al-Supa from North Carolina State University. Just a brief outline of what I'll be presenting today. I'll first start with an introduction to California strawberry production, followed by the survey of soilborne pathogens infecting strawberries in Oxnard, California, followed by the second part of my thesis, the effect of planting day and chill treatment on the yield of strawberry. So a brief overview of the fruit production in California. California market, it's 90% of the strawberries grown in the US. It's a huge commodity in the state. It's valued at $2.68 billion in 2022. And we have two production seasons. We have the fall planting. Fall planting occurs in Watsonville, Salinas District, Santa Maria, as well as Ventura, Oxnard. And then we have another summer planting season. This occurs in Santa Maria and Oxnard exclusively. Now, taking a look at California nurseries, this is also a huge industry within the state. 1.5 billion plants are produced annually, and we have high elevation nurseries. You'll see those top two red circles up in the McDowell area. These are harvested September to August, and they supply plants to California, Baja, Central Mexico, Florida, and California. So those go everywhere within the states as well as beyond our borders. We then have the low elevation nurseries. So these are in the Central Valley area, and these are harvested December to January, and 70% of these transplants are used for summer planting. So again, summer plantings is going to be the Oxnard and Santa Maria districts. Now, a huge cause for concern in the strawberry industry is soilborne pathogens. You'll see a photo of an affected field. You can only imagine what a grower sees when they see this. It's a major cause for concern. So the historical pathogens of strawberry, and by historical, I mean pre-methyl bromide phase out, include Verticillium dahliae and Phytophthora species. We then had methyl bromide taken away as a fumigant. So methyl bromide was taken out because it has ozone depleting characteristics. So the environmental impact was too large. So it was phased out, and then we saw the pop-up of Macrophromina phasiolina and then Fusarium oxysporum, form of species Fragaria, races 1 and 2. So I just want to give a brief overview of these pathogens because they are the main source of study in these surveys. So Macrophromina phasiolina causes the soil-borne disease Macrophromina root rot in strawberry. And one thing to keep in mind is it prefers dry soil and high temperatures. This is when we see germination. It has a wide host range, including 74 confirmed hosts, and it produces mycosclerotia that you can see in this photo on the right. These can survive in the soil for up to 15 years. Moving on to Verticillium dahliae, this causes a soil-borne disease, verticillium wilt. And something that we see often that's interesting is that lettuce is a commonly grown crop here in California, and it's a great host, unfortunately, for Verticillium dahliae. So we often see this rotated with strawberry. So you'll have a field of lettuce planted that jacks up the rate of Verticillium dahliae, and then a lot of that plant material is then incorporated into the soil. So you have breeding grounds for Verticillium dahliae, and then you come back in and plant strawberries. It has a wide host range of over 200 confirmed hosts, and again, produces mycosclerotia that can survive in soil for long periods of time. Moving on to Phytophthora species, this causes Phytophthora crown and root rot in strawberry. The most common species we see are Cactorum and Fragaria in strawberry. It's commonly characterized by its red rust-colored crown discoloration. And something unique to Phytophthora versus the other four main pathogen is that the sporangia release zoospores that travel via water. So this is a pathogen that loves cool conditions and wet, oversaturated soils. Finally, we have Fusarium oxysporum, form of species Fragaria, or FOF for short. This causes a soil-borne disease, Fusarium wilt in strawberry. We were able to identify the FW1 gene, and this is bred into germplasm to provide resistance to race 1, but recently race 2 was discovered in a 2022 planted organic summer field in Oxnard. And to date, there are no strawberry cultivars that are resistant to race 2. So this is a huge, huge cause for concern. And it was also recently found that there's airborne spores that are released by Sporozoa that can also infect the plants via petiole. So it can be airborne as well as soil-borne. So how do we manage these pathogens? Pre-plant, we have soil fumigation. We have both flat fumigation and bed fumigation. You saw a great example as you drove in a flat fumigation. This is quite literally flat ground covered in a plastic, and there are fumigants injected into the soil. Then there's bed fumigation. So this is when the strawberry beds are already formed and we're able to inject the fumigant directly into the soil that will be planted. Then we have end of season measures. So this includes crop termination. This is something that's been explored in depth here at the Strawberry Center. This involves injecting a chemical or fumigant in some cases into drip lines. This kills the plants that are living as well as any inoculum load that's in those plants and in the soil. We also have cultivar resistance, which I touched on a little bit earlier, crop rotation with non-host plants. And then in the case of organics, we often see anaerobic soil disinfestation, steam, and cover cropping as measures. With that, I'll be moving forward into the survey of soil-borne pathogens infecting strawberry in Oxnard, California. So I want to start off with, why does this all matter? Imagine if I were to ask you, what are the most common diseases in humans? And this is what you gave me. It's not much. All it's telling me is that There are diseases out there. We don't know how prevalent they are, what they are, how they spread. Now, what I would be looking for is this. I want to know the prevalence of these diseases, and it's more than just the graph. These diseases are spread through different ways. They have different control measures, and with that, we can maybe look at the geographic distribution. And with that, we can also see, what our causes are. There certain trends in where we're seeing these diseases and management of them. So keep that in mind as I move through this survey. Now we'll go back to the 3 districts. So Watsonville and Salinas was surveyed by Mary Steele, a previous grad student from August to November of 2021. This included 74 samples from 69 ranches and is 33% of the district acreage. And as a reminder, Watsonville only plants in the fall. Mary Steele also conducted a survey in Santa Maria from June to September of 2022. This included 1 fall planted and 1 summer planted sampling. And then finally, the last piece of the puzzle that completes statewide survey and all 3 main growing districts is Oxnard. So the objectives of this pathogen survey. We wanted to evaluate the distribution of the 5 main pathogens infecting strawberries in Oxnard, California. We also wanted to conduct statistical analysis to analyze associations between agronomic practices and the presence of these pathogens. And finally, as I discussed, the Fusarium race 2 was recently discovered in Oxnard, so we wanted to identify any new sites of this to see how far it had spread before we knew, and with that, different containment measures. And the hypothesis was that Macrophormina phaseolina would be the most predominant soil-borne pathogen in Oxnard. And this is for 2 main reasons. First off, it was first discovered in Oxnard. And then as I discussed previously, it really, really thrives and germinates in those dry, hot conditions. As we move through Southern California, Oxnard tends to have the most dry and warm conditions. So it's very conducive for Macrophormina phaseolina. So the methods of this survey. So we first would observe fields where we see any symptomatic plants. So symptoms are going to include any necrosis, so dead tissue, chlorosis, discoloration, or stunting of plants. I would then collect plant samples, which consisted of 8 plants, bring those back to the Cal Poly Strawberry Center pathology lab where they would be processed, and then this is a picture of the crown. So this is the actual plant just opened up. And you can see we've observed discoloration, which is tends to be a sign of the presence of a soil-borne pathogen. And we would then perform a crude DNA extraction, which we would then perform pathogen diagnostics. In the case of the survey, we use a commonly used diagnostic molecular tool called RPA, or recombinase polymerase amplification. Finally, a grower report would be sent to the grower so that they know what the issue is in their field. Taking a look at the sampling area. So I sampled from November 2022 to December of 2023. This included 93 samples from 82 ranches. This covers 67.6% of the planted 2023 summer acreage, and then 23% of the 2022 fall acreage. So our method of diagnosis, again, there's a picture of plants. Samples included 8 plants that were brought back and processed. A crude DNA extraction was then performed on the crown tissue, and a molecular tool, RPA, was used to diagnose the presence of a pathogen or not. And with this molecular assay, we also have an internal control where we can confirm that our DNA extraction was successful. Finally, if the sample came back negative for all of the main soil-borne pathogens we tested for, we would then plate plant material. This includes roots, petioles, and crown tissue to confirm the absence of the main pathogens we're looking for. Now, something that was a little side note that we weren't necessarily looking for, but is a part of the plant processing, is Meloidogyne species. So these are root knot nematodes. You can see on the bottom left a photograph of a nematode, and you can see what the symptoms look like in root. So you see a gall, it almost looks like a pearl, and you see inflammation of the root tissue. We had 2 samples from 2 conventional fields, and in both cases there was co-infection. So there was Meloidogyne, or root knot nematodes, as well as Macrophormina phaseolina. For data analysis, so in field, I collected data on the mulch color, number of drip lines, conventional organic, as well as the soil type. I then performed nominal logistic regression to see if there is an association between any of these factors and the presence of these pathogens. So it would be like, in reference to the earlier disease, it'd be like saying, me being able to say if you drink coffee, there's an association with a certain disease. That's the goal, at least. This was analyzed using JUMP statistical software version 17. Now look at the results. This is the summarized results of all positive samples. You can see that Macrophomina phasiolina, as hypothesized, was the most prevalent pathogen, followed by Fusarium race 1, and then you can see Fusarium race 2, Phytophthora verticillium occurred at much lower frequencies. Now, if we take a look and break up the different seasons, so graph A and graph C are both going to be the summer planted. So you can see a high prevalence of Macrophomina phasiolina. Again, the summer planting, we have those high heat events and low soil moisture. And then graph B is showing the fall planted. So you can see there's actually a higher prevalence of Fusarium race 1, followed closely by Macrophomina phasiolina. So the main takeaway, Macrophomina phasiolina was the most prevalent pathogen in Oxnard from 2022 to 2023. Now taking a look at the agronomic practices that I mentioned earlier. When looking at these graphs, they can tell you a couple of things. One of the main things that I want you to take a look at is if you look at the horizontal axis as 100%, so it's 100% of our samples. Now, each of these factors, so black, plastic, clear, green, skunk, white, and white with black sides, the width of those is the percent of 100 that we observed in the sample. So, for example, if you look at the black category, that looks to be roughly 10% of the horizontal axes. So that means roughly 10% of our fields had black plastic.
Hey, Sam.
And that will be the case moving forward with these graphs.
How you doing?
So
I'm
in the
doing great.
case
How
of
are
plastic
you?
color, we did not see any association. We're
man.
looking for a
Doing well.
p-value
So,
under
I'm
0.05.
the calibration. Help
So
I
no
figure out if
association
we have
between
enough
plastic
product.
mulch color and
Yeah,
pathogen presence.
totally.
The next
We're
agronomic
good on
practice we looked
Movento. We
at was
got
the
way
number
more
of
than we
drip
need.
lines.
Yeah,
So
I mean, John,
in
a
all
lot of
fields,
that
we saw
belongs to
either
Johnny,
2,
but
3, or 4 drip lines. And
yeah,
in the
well,
case of drip
I'll
lines, you
talk
can
to
see an
him about that.
asterisk next to Macrophomina
A lot of
phasiolina and
concrete
Fusarium
jumping
race
stuff that we're
2,
gonna have to get
as well
more
as
about
a
that,
p-value lower than
Okay.
0.05. So
And
that
then
indicates
we have
statistical
9 gallons of
significance.
Omni oil that I believe that belongs to Johnny
So there
as
was an
well.
association between
Okay.
fewer
I
drip
think
lines
that
and
would be
presence of
just enough
Macrophomina
to
and
do
race
the
2. And
application,
again,
but if
to
you
note,
want,
Macrophomina really
you need to
likes
get more, I would just
dry
pick up 10 gallons of
conditions.
Omni
Dry, hot
oil.
conditions are
Cool.
conducive to its germination.
And then dynamic, we only have half
Now,
a
if we take a
gallon.
look at
So
conventional
we're gonna
versus
need more
organic,
dynamic. Okay. Yeah,
there was
I'll
not an
put in an
association
order
between
and I'll tell
the
them that
presence
we
of these
need
pathogens and
dynamic
either
to be
organic or
dropped off
conventional practices.
tomorrow,
And one thing to note,
and
the
the other
width you'll see
stuff
on the
we can
conventional is
replace
large. This
Johnny's
represents
stuff
what we know
unless
about the acreage. About
he needs it, but I
75%
think
of the acreage in
and
Oxnard
I'm
is
sure, I think
conventionally
he's still here, so I can go
practiced.
double check on everything.
Again, no association.
Yeah, he said he was
Now
going to be
looking
around
at
till
soil
4.
type, majority of samples were in a loam.
Yeah, he hasn't turned on
And
the
again, we
lemons
did
yet
not see
either,
any
so
statistical significance between
but
soil
you
type and the
might be able
presence
to
of our
find him over there.
pathogens.
Totally.
So
Alright,
in
yeah.
conclusion,
So I think
Macrophomina
dynamic
phasiolina
is
was
just
the
gonna
most
be our
prevalent pathogen in
limiting
Oxnard from
factor, so
2022
cool.
to
I think other than
2023.
that, we're good to go, man.
Fusarium
I'll call
oxysporum
Francisco and get it
formospecies
dropped off
figurae
tomorrow.
race 1 was the most
I
prevalent
guess let me
pathogen
know if
in
you want to
fall
throw anything
planted
else in the
samples
tank.
only.
But I think with just those 3, we should
And
be
we found an
okay, right?
association between fewer drip lines and the presence of
Yeah,
Macrophomina
I
and
mean, there's always foliar stuff like you did
Fusarium
in the
race 2.
lemons, like low
Now we'll move into the second part of my
urea.
project. This is more a plant physiology base. And
Citrus
again,
loves
this was in
urea
partnership with North
foliar.
Carolina State University.
Okay, we
So
have
as
some
an
of that laying
introduction,
around
in
too.
this
I can
photo,
toss
you'll
that in
see
there.
on the
Yeah,
left is a plug
let me
plant, and on
sleep
the
on all
right is a
that.
bare root plant. Bare root transplants are
And
exclusively
gosh,
used
there's also like that phosphite,
in
but
California
not with
production. And
oil.
some of the reasons for that include that they're easily transported. They can be tightly packed into big
Like
boxes
for
with
that
no issues,
rot
and they're
stuff, but
conditioned to field
let me sleep on all that, and I'll
environments.
decide if we
Whereas
want to
plug
make
plants are used
something in the
throughout eastern
tank.
United States, so North
And
Carolina, New York, any eastern
and
production,
but
which
yeah,
in
I
general is much
really
smaller scale
appreciate
than
you checking
California.
in on the inventories. That's really
With plug
helpful.
plants, they have the ability to control
No
clean
problem,
stock,
man.
and part of that is because they're grown in
We're
controlled
gonna need
environments.
40 ounces of Movento. I believe
So the
about the 9
objectives
gallons of Omni
of
oil
the
should cover it,
planting
and
date
then
and chilling
I may have
trial
to buy 5
include
gallons of
determining
dynamic,
the
so that would
effect
be more
of
than
planting
enough.
date on yield
It's
of
not
Monterey and
5.
Fronteras in the 2022
They're
to
coming
23
5.
season.
Oh, yeah.
Then to determine the effect of a chilling treatment on yield of Monterey from
I think I can
2023
do
and
by
2024
2.5,
season.
but I like having it
And with
around,
that,
like
we
you
want to
said, so
determine the
5
feasibility of producing plug plants in North Carolina, shipping them to California and planting to produce fruit, because again, California exclusively right now uses bare root transplant.
Totally. But
So the
but
methods of
total,
plant
we're gonna
production, this
use
is where
a
NC State
gallon,
comes
Sam,
a
do
in.
you hear
little
me?
over a
So
gallon, like 1.7
all
gallons
plug
or
plants
1.07
were
gallons, something like that.
produced by North Carolina State
Cool.
University. Daughter
Sweet.
runner plants
It's,
were planted
I guess we
into
could say all
trays.
this rely
These
just
were
for
again
avocados.
grown in controlled environments, so
Those
under
10 gallons,
artificial lighting and
absolutely.
irrigation systems. And then these were removed and they were
If you
shipped
talk to
to
Johnny,
us
ask him
overnight,
what
where
he
we
thinks, but I think
planted them the
saving
next
that
day.
10 gallons for just avocados
So the
should
first
be
part of this
enough.
project is planting date. Again, this
We
was
were
done in the
chatting about it, and he's like,
2022
dude,
to
tape that
2023
up, right?
season. A
Avocados
split
only,
plot
maybe
design
hide
was
it somewhere.
utilized with the main
I think we'll
plot
be okay.
being the planting
These
date and the
dolphins are really the
subplot
only
being the
ones that go in
cultivar.
there.
Again, we use
I
Monterey
don't
and
think Sam can
Fronteras
hear
as
us,
the
but someone
seed.
needs to mute.
Dan shit
Yeah,
is
In
on
terms of
there.
data collection and analysis for
And,
both
but
projects,
I
we
don't
harvested
have any
trace
host
weekly. In the
capacity,
first
so
year,
I
that was
can't
from the
mute.
13th of April through the
Perfect.
10th of August. The second year, that's the
Alrighty, man.
29th
Well,
of
I think
March
we're
through the
all
3rd of
set.
August.
So it's
Fruit
looking
was
like
weighed
it's
and
gonna be,
counted and
if we're
analyzed
doing the
on a
whole
yield
block,
per
it's gonna
plant
be
basis.
about 600.
With that, there's a weekly plant mortality counts, and these were plated for disease screening.
One small tank.
At trial
Awesome.
termination, so when the trial is completely done, we took a look at the number of branch crowns in each
Hey,
plant, and this can be used as a measure of plant vigor.
Yeah, I'll text
And this
with
is a
you
photo you'll
tomorrow,
see. This
and
is
I'll
the
look
main
forward
crown,
to
and then the
seeing
branch
you
crowns are
on
secondary
Friday.
crowns off of that main crown.
And
And data was
let's
subjected
just,
to analysis of variance of
oh
one-way
yeah,
ANOVA
so
and Fisher's
Friday
LSD mean
is, I get
separation,
in kind of
utilizing
late on
ARM.
Friday some days. I was like,
So the
yeah,
results
let's
of the
just do an
first
early
trial, the
Friday,
yield,
but
we'll
the Friday.
first look at Monterey. You can see during the peak harvest around the 25th of May is when we saw the largest separation. So we saw a 37.8% decrease in total yield per plant with a 2-week delay in planting, followed by a 69.9% decrease at 4 weeks. Now, if we take a look at Fronteras, we saw a 29.5% decrease in the 2 weeks delay. So that's going to be the blue line. And then a 51.4% decrease when planted 4 weeks later. That's going to be that orange line. Now, taking a look at branch crowns again, this is our measure of plant vigor. So in Monterey, we saw statistical separation between planting date as a predictor for the number of branch crowns per plant. So we saw the highest number of branch crowns with earliest planting and then a stair step after that. Similar with case with Fronteras, where again, we saw statistical separation. We saw the highest number of branch crowns per plant with that earliest planting date and a stair step down. And error bars represent standard error of the mean. Now, in terms of plant mortality, we didn't see as much of a trend. So particularly in Monterey, we didn't see any statistically significant separation, and there wasn't really a trend in terms of plant mortality. Now, when you look at Fronteras, we do see a little bit more of an expected trend where we see higher percent plant mortality with later planting, but again, nothing that is statistically significant. Now, moving into the second part of this project, we looked at the effect of a chill treatment on strawberry yield. For the chilling treatment, again, these plants were produced at North Carolina State University. The cultivar used was Monterey. These plugs received 350 hours of chilling at 4 degrees Celsius and a photo period of 18 hours. These were fertilized using their standard practices. Now, a complete randomized block design was used. You can see a screenshot of the fields. And the last plot, we did observe an edge effect. So you can see we have some plant stunting and higher plant mortality, particularly on the right end of this plot, which is right at the end of the bed. So this was removed because we did observe an edge effect. Now, taking a look at the yield, again, this is analyzed on an average fruit weight per plant, and you'll see the chill trial continually outperformed the no-chill trial, and those asterisks indicate a statistically significant difference. Again, we took a look at the number of branch crowns. No statistical separation between two treatments, but we did see a slightly higher number of branch crowns in the chilled treatment. And in terms of plant mortality, we did see statistically significant differences. So you can see the letter code A on that no chill. We had much higher plant mortality in comparison to our chill treatment. In conclusion, Macrophormina phaseolina was the most predominant soil-borne pathogen in the Oxnard growing district. The number of drip lines had significant impact on the presence of these 5 major soil-borne pathogens that we tested for. In terms of the second part, the more plant physiology-based trials, the chilling treatment and planting earlier in the typical season increase yields and plant vigor. And limitations, there's always limitations to these trials. So in terms of the survey, we would recommend repetition of a full survey every roughly 5 years to see if there is a shift and monitor that. In terms of the planting date trial, there is, as we know, weather variability season to season. So, and we would expect to see a shift because of that, because there might be a weather event that would change the results. And with that repetition of both the planting day and chill trials, there are plans to replicate the chilling trial this planting season. These are all of my references. And with that, thank you for listening. And I'd love to welcome any questions.
All right, time for questions. Any questions for Sam? We have plenty of time, and the committee will be asking lots of questions after this session. This is a chance for you all to ask questions. They have questions about the way this was done.
In terms of the plug plants, they seemed a lot bigger in terms of, the
Yeah.
is that usually how they come, or are they usually shorter in terms of height, or?
So that is accurate to how they this is accurate to how they come in both the case of our trial and industry standard. One thing that I observed is that there's the idea that these plants are ahead because they come with foliage on them and they look so beautiful. But in the case of our trial, both years when these plugs were planted, we actually saw necrosis of a lot of the older tissue. You do start to see new growth that actually kind of comes up around the same time as the bare root transplant, and then a lot of necrosis of this of the first tissue that comes within. The really leggy plants as well, because they're grown under artificial light, so they do look a little bit different. Yeah. Kyle.
When the East Coast plants these plugs, do they see the same type of necrosis on the leaves, or do they grow differently in that environment?
That's a great question. So I should be repeating the question for Zoom. So the question was if they see similar necrosis of that first foliage in planting systems in the East Coast where they're traditionally planted versus what we see. I think that a large part of it has to do with the weather, especially when we see the heat, the plants seem to dry up a lot faster. I'm not completely sure if they normally see that. I think that they normally have higher humidity, and I do think that the dryness is part of, they just almost crisp up here in our setting, even with overhead sprinklers. So, yeah.
For the plug plants on the East Coast, so that's all like some sort of potting mix, and it goes into go into the ground. And what kind of soil is typical of like East Coast strawberry production?
That is a great question. So the question was, what soil type do they normally have in East Coast production, and maybe how the plug plants are produced in.
Curious how did that interaction, because that's like when I go to Home Depot, I get a tomato, I stick it in. If I stick it in just the plug, it doesn't take root as well. I have to mix it with the indigenous clay in order to get a better result. So
Sure.
I was wondering what happens on the East Coast.
Yeah. One thing I know with East Coast in general, it's smaller production. So part of, in my mind, the maybe con of using a plug plant is there is so much soil. So actually planting that is much harder than just a tool and putting the roots in of a bare root transplant. In terms of the typical soil type in North Carolina production, I'm not familiar with. Cooper.
Thinking about the survey, when a grower would get when they look at those pie charts of like, okay, there's more macrophomina than fusarium, or even like fields.
Uh-huh.
The field has more MAC than fusarium or verticillium or something.
Mm-hmm.
How do you think they would change their management strategy from year to year? Just thinking about soilborne pathogens.
So like depending on the result.
Yeah, like if they had more MAC than fusarium, is there something that they could change
Ye-
on their side?
Yeah, so for people on Zoom, the question was depending on the results of what pathogen is present, what maybe different management strategies would they implement for future years? So one thing again that I think is interesting is that we saw an association between fewer number of drip lines and the presence of macrofermin. And it makes sense because it germinates in these dry conditions that are naturally happening and drier soils. And again, that association was with the fewer number of measure that could be implemented. In terms of fumigation, there's fumigant options that ideally would fully wipe out any pathogen that is present. We did see, interestingly, a law of co-infection of Fusarium race 1 and Macrofermina. So I do think there's some cases where the fact that there's a pathogen there is the measure, not necessarily what is there, and especially in the case of co-infection. Yeah. Colette? Oh, yeah. So that is Fusarium, I'd say it's also an opportunistic pathogen. So if we see low soil moisture, and there's plant stress caused by that, then the plant is more susceptible to infection of a pathogen. But I'd say the biggest note with a high soil moisture is we often see Phytophthora because those are very conducive conditions for Phytophthora.
Question? Might go on. The bar charts, the box charts.
Sure.
You go to the one with the plastic color.
Plastic
That's the
color.
one. Yeah. So no associations between plastic color. Can you go back one more so that you don't see the?
Yeah, the huge box on it. Yeah, let me get. Oops. Let's see. Where are we?
Yeah.
There we go.
Yeah, so you say no associations, and yet that skunk bar looks really, really high.
Mm-hmm.
Why wouldn't that be different if it's so high compared to, say, white or black plastic?
Now, I think part of that you can see also in the graph that it's such a small proportion of the total samples.
So less than 10%.
Yeah, I would say, yeah, less than 10%. Yeah.
Is that the reason? Do you think if you had a larger sample size, you would
I would
actually,
feel more,
cats would pull out the-
yeah, I think they would, or we would maybe have, a higher, it's like more repetitions, we'd have a higher confidence level. And the stats would possibly.
And does that make
separate.
sense that skunk plastic would, how would you explain that then? Let's say it's real and all you need is a larger sample size.
Mhm.
What would that mean? What would that explain? Why would skunk plastic result in such a higher level of disease?
Skunk is interesting because it has a white top with black sides. So I think that incorporates, with the black plastic, we normally see higher temperatures. And then the white, we normally see cooler temperatures. So my thought would be that having both black and white,
What is
more
skunk
of,
though? Is skunk white?
yes, white with black sides. And then you can see we also had a clear, as
Skunk is
well.
clear on the top. It looks white. It's clear.
I see. So sorry, it's so hard to keep track of skunk, zebra. So I think actually this one over here on the, oh, you can't see my mouse. The far right is going to be the white with black sides then, and the skunk, you're correct, is clear with black sides. Clear plastic, actually, a lot of times like a greenhouse, it actually can really increase its heat can get in and can't escape. And a lot of times you'll actually see condensation all over the plastic. So I would think that would have would potentially cause higher disease.
Questions from the group?
Oh, I was curious about something. What's the significance of the chill, studying the chill effects that related to where they're from, the fact that they're grown in Northern California, part here, or the fact that you source strawberries from out of state?
So it's more so the opposite in that we grow at high elevation because we can get the chill hours naturally, whereas in a controlled environment, they have to artificially apply the chill treatment. So chilling increases the plant's vigor and the flowering when they are actually planted and during the fruit production season. So that's why we see the chill, applied chill. And again, in the high elevation, they are naturally, I want to get back to this slide, naturally occurring. And then a lot of times at the low elevation, those plants actually end up going up to the high elevation nurseries to be planted to again get those natural chill hours.
Can you get chill hours in low elevation?
You can get them, but normally you need supplemental on top of that. So again, they'll go up to high elevation, or you can also put them in cold storage to a supplemental chill hours. If you didn't get what you need in the nursery, you can get those artificially in cooling.
There's one question on the chat.
Yeah.
Rita,
Okay.
maybe outside the scope of the project. The question is, does KPAM run one time or two times as a crop termination reduce fusarium levels in the soil?
Is that Jack Costing asking? That I believe is outside the scope. Shashika would have maybe the answer to that. I haven't explored crop termination personally. We have done trials here that I have not been a big part of. I know KPAM was a treatment. I don't know if it was a single application or not, and it was for verticillium, not fusarium. So I don't even know if that's been explored actually for fusarium.
Maybe a little bit.
Yeah.
Can you go to the slide where you have the yields?
Sure.
The two varieties.
Mm-hmm. Give it 1 second. I don't want to freeze this. There you go.
Yeah, so Monterey looks like it did better than Front Terrace.
Mm-hmm.
So why would anybody plant Monterey? Or Front Terrace, I'm sorry.
Why
would
would anyone?
plant Front Terrace?
Well, everyone wants to plant Monterey.
But not everybody does. How many people, percentage of the acreage is planted to Monterey?
Monterey, it depends on the season. So Monterey is the most predominantly planted in fall plantings. Whereas Front Terrace, I mean, there's trends with it too. We see Monterey has actually started to reduce a little bit in terms of its acreage compared to what it has in the last couple of years. There's a lot of variation in the responses and general physiology of strawberry plants based on the cultivar. And this is something that can't be emphasized enough. I think we see it with plant structure. Just anyone who's walked our variety trial, you can see visual differences. So a big part of that, Monterey is a day neutral variety. So the day neutral produce like a marathon, whereas the Front Terrace is a short day, and those produce like a sprint. And a lot of people, Monterey is planted and grown in high acreage, and part of that is because it's known for its really high season-long yield. So it gets high yields and it produces for a really long time in comparison to a short day like Front Terrace. Kyle.
So looking at this chart here, it looks like earlier plantings get more yield. I know that we kind of plant early November, late October, but should we be thinking about if we were trying to increase our yields here, planting earlier in October? And how early would you is ideal to maximize your yields?
So that's a big thing that I want to be hesitant with saying is it's not earlier yield, like the earliest you can do. Why don't we do January 1st, the first of the calendar year? It's a fine line, right? And strawberries, I think in particular, can be what's the right word? not finicky, but very particular. They like very moderate weather. That's why they're grown on the coast of California, because we don't in general get really extreme heat or freezing temperatures. And when we do, the flowers aren't happy. So this is, I would say, I think we plant a little bit later than what maybe commercially they do. I think normally down in Santa Maria, you know, they're more like mid-October, and the early November time is actually a little bit late for them. We're just a little bit behind that. So I would say early for a typical planting, not just the earliest that you possibly can. Part of this too, from a grower perspective, is to try and optimize when you're getting your yields. You know, you want to have yield when the market, there's not a lot of fruit on the market, just supply and demand. So did that answer your question?
Mid-October
Yeah.
is better than late October, and maybe early
And-
October is better than mid-October, and then
Oh.
late November is better than. Where does a grower draw that line and why?
Part of it, I mean, outside of the research, I try and think, how does this apply to a grower setting? Part of it is just what they can do. How fast can they get fumigation? How fast can they get labor to get everything in the ground? In the case of the November 23rd planting, as soon as those plants go into the ground, they don't establish as well because they have a lot of rain normally. And cold temperatures. But again, a lot of it depends year to year. So this is a snapshot of 1 year, and there would be a lot of replication needed. And again, it's variety dependent. So depending on the variety, I think this needs a lot of replications to really nail that down, because weather's the largest variable really in that.
So if you could dictate the weather.
Yeah, I think
could
anybody.
Say, here's what I want,
Mhm.
and then get that, what would it be? What kind of weather would you want at transplanting? What would you want then between there and so just within reason, right? We have
Yeah.
fall and winter and spring. But you know, fall can vary quite a bit, winter can vary quite a bit, but what ideally would you hope for?
I would hope for not a lot of heat so we can keep the soil moisture, especially when those micro sprinklers are growing. The crowns really need to stay moist. If they dry out, they have a really hard time establishing. So I would say fog, no freezing temperatures, but also not a lot of heat so that we can keep that soil moisture and moisture on the crowns. Yeah. Steven, yeah.
Do you think there might be a benefit in using, like, I don't know, like plug production, like strawberry plants, like earlier in the season to combat like some of those weather challenges that like berry transplant might have?
Yeah, so for those that didn't hear on Zoom, the question was maybe essentially if a plug plant would maybe respond differently to these weather events that might affect a bare root transplant. I would say that the optimal conditions are almost identical for both. They're still both strawberry plants, right? So they have ideal conditions for both of them. And I would say in the case of plug plants as well, they really shouldn't dry out, because that's when we especially see necrosis and drying of the tissue that petioles and leaves that they first come with. Yeah.
What's the biggest disadvantage to, you mentioned our industry is all bare root transplants. Let's say that using plugs was significantly better. What would be the biggest challenge in changing over our current system to adopting a plug transplant system?
So for those that didn't hear on Zoom, what would be the biggest challenge of if we one day decided to switch from bare root to plugs? I think if we're thinking in a like feasibility sense, there would obviously be a lot of infrastructure change. I personally think that planting plugs is a bit more difficult. You see how quickly workers can go through with a bare root, just sticking it in the ground with a tool and packing it really quickly. If you break off a few roots, it's not the end of the world in terms of plant viability. Whereas when you have plug plants, you have this top that you're trying not to snap off because that is the plant. Because these plugs are grown in controlled environments, sometimes sticking them straight into a field, they're not well conditioned, whereas the bare root we have are well conditioned to different environments or climates. I just think overall they're hardier plants because they're grown in a field in an outdoor setting versus a controlled environment.
Other questions?
Yeah.
Mortality you talked about,
Mhm.
were you referring to can you clarify whether you're referring to mortality due to diseases or establishment?
Sure, yeah. So we took plant mortality, a percent plant mortality in both trials. In the case of these figures, that's based off of disease. So it's what we saw after plants had established and had fruited, and then we saw necrosis.
And what was the pathogen usually?
It was more than one, but in most cases it was verticillium. Yeah. And these were both planted in 25, which is just across the creek here at California, both in different blocks, but same fields.
Did any of your findings surprise you, or this is kind of what you expected?
I would say it's generally what we expected. I think the survey was the most, I mean, we had a hypothesis, an educated hypothesis, but there wasn't as much, background. I think with the surveys, there's a lot of speculation, and you hear, well, Johnny found verticillium, and whereas chilling is something that we generally know and has been proven since the beginning of large-scale strawberry production that chilling is required. So that didn't come at a huge surprise, but I think the survey was a more kind of blank slate, and just more maybe speculation, not as educated of hypotheses. Yeah.
You figured that chill would be different, but you didn't know how different.
Yeah.
That's really, of course, it would be really surprising if chill had no effect.
Yeah. Yeah.
Any other questions? Then let's thank, we got one more on the chat.
Okay.
She's curious how important you think it is that race 2 is overtaking race 1 in prevalence. Will that actually matter when growers are making decisions? And do you think it will eventually become prevalent enough to impact their decisions?
That's a great question. Did they hear that? Is your speaker on? Or I guess anyone on Zoom can see the chat. Yeah. Yeah. So race 2 hasn't overtaken race 1 in prevalence. And I don't think it's on its way, at least not yet. Because this is such a novel finding, I think everyone's trying to be as proactive as they can about it and stop the spread. I often hear growers, I think, thinking a little bit more about sanitation practices, which is great because, again, we're really concerned about the spread of this. Will it actually matter when growers are making decisions? I think part of it too is the plant breeding, if we're able to identify any gene that could overcome race 2. So that is a really important part of the timeline on race 2 and how fast it spreads. Do I think it will eventually become prevalent enough to impact their decisions? Again, I think I hope not. I hope it doesn't become that prevalent. I think they don't either. Again,
what about for the grower who has it?
Yeah.
Is it prevalent for that grower?
Oh, definitely. And in terms of the plant die out in race 2, it's astronomical. I mean, it's just wiping it out. And that's why it was first raised as concern. So I do think that growers are trying to be as proactive as they can. And obviously the finding of race 2 is a major cause for concern, but I don't oversee it hopefully overtaking the prevalence of race 1, just again, because people are being so proactive about it, but that's not to say that it can't spread. I think if it was in our breeding systems, then that would really be a major issue, because that's how, you know, we do see pathogens that come on bare root transplants, and that's obviously a huge potential for spread of a pathogen.
So for those few growers that have race 2,
Mm-hmm.
since they cannot use a resistant variety,
Mm-hmm.
what can they do? What's available to them for management?
Sure. Yeah, so crop termination, this would be a great case of crop termination because they already have a crop in the ground. And obviously Fusarium race 2 in the ground. So I think this is a great option to use crop termination. I think in the case of any site that we have tested positive for race 2, that ground is now fallow. And I know there are cases where leases are years, multiple years. But I would suggest not planting strawberries back to back, obviously. And hopefully with that, we would see a decrease of the level of inoculum without a host plant.
So I'm gonna go one step more. What if? You know, grower doesn't have a lot of options, maybe.
Mm-hmm.
This is a really important piece of ground, and this lease is not up for another 2 years.
Mm-hmm.
And it's gotta go, it's gotta make it go. So what are his options? You got crop termination. Not planting doesn't sound like a good option in that case. Is there anything else that?
I mean, unfortunately, planting a resistant cultivar is obviously not an option in the toolbox anymore. I would suggest, I mean, if it was organic, if they could change to conventional so that they have more maybe potent options in the toolbox, but their, I think, organic grounds is a prize.
Let's say, okay. The grower agrees.
Mm-hmm.
Just gonna go in the towel, the organic, go conventional. What's the best option?
Fumigation would be step one. Well, crop termination of the current crop, good sanitation measures and to reduce the spread throughout their ranch or any other ranches that this equipment's being used at, and then fumigating pre-planting. In terms of cultivar selection, which is a common measure and tool to use, that's again not an option in the case of race 2. So I don't know that I mean, it's somewhat of a gamble, I think. Yeah, it's an yeah, it's an unfortunate situation. Yeah, and yeah, part of the survey was, so it's, you know, it's hard because as pathologists, it's like, oh my gosh, we found race 2. Like, it's not exciting, but we found a new site, and you know that brings up questions. But at the same time, it's the worst nightmare for a grower. So yeah.
Yeah, and what do you know what happened in?
That's what I'm trying. Ito is still farming. I know that. And again, we get in the diagnostics, we've actually this week gotten samples where they're trying to see how far this is spread. And I don't know if part of that is because they might leave the ground where it is fallow, or again, the sanitation measures of only utilizing equipment in the positive race 2 area, and farming a little bit differently in other areas of the ranch. Yeah. But it's unfortunate. Yeah.
I think in one case I'm thinking of where the first actual detection of the pathogen, I think the grower left the field.
I do think
Put it
so,
up
yeah.
for lease.
Yeah. Yeah.
And maybe they'll grow another crop there. I
Yeah.
don't know.
Yeah. I would never suggest strawberries
I-
again. Yeah. Yeah.
Piece of ground, you want to know what the history is.
Mm-hmm.
You want to know what other crops have been grown and what problems they might have had. Right? Just like buying a used car or something. All right. Any other questions? I think we've gone a good 20 minutes here on questions. So that gave us a good opportunity. So thank you again, Sam. Let's